Welcome back to this series of videos on data engineering. We are looking at how to build a machine learning pipeline using Azure Machine Learning Studio. In the last session, we have completed making the draft pipeline. Now we have to submit this as a job. Once we submit this as a job, if all the configuration is correct, then it will run successfully and it will give me the output. So let us go to configure and submit. Now, we last time had already created an experiment where we had submitted a job to find out the missing values. So we can select the existing experiment, okay, instead of creating a new one. And we can say the job display name as complete pipeline, just to differentiate from the earlier pipeline, which was just to find out the missing values. We have to select the compute instance, or our compute instance is running, so we'll select that and we'll submit. The moment you submit, we can see that the pipeline job is getting created. It will soon get submitted and will start running. Job has been submitted. So if you go to the job, you'll now see another new job, because previously there was one job which just got completed, but this job is a new job. We said that these jobs are grouped under experiments. Since we did not create a new experiment, this job is under the same experiment. However, it should be a new job. This is a new job, complete pipeline, that is running. Now, if you go to this job, we'll see that how the job is progressing. You see here that this is green, that means it's already completed because it was done earlier. Now here we see blue hash, and these two are blue hashes, which means that these two jobs have been submitted in parallel and they're in queue. Okay, they're in queue to be executed. Once the execution starts, it will become hash green. Um, If it is hash gray, that means this job is yet to be queued. So no action has been taken in the other components, and that's why it is still white. So it will run one component at a time. Now you may be thinking that if we do this in Jupyter and Colab Notebook, it takes much less time. Yes, that's true, because this entire infrastructure is built for very large data. So what happens is that if it is a small data set, it takes the same amount of, or it goes to the same amount of process, and hence a small data set will take almost similar time like a large data set. You can see here that this is hash green and this one became complete. So hash green, and now it has become dark green. So hash green means the job is under process, and dark green means it has been completed successfully. If there is any error, it will become dark red. Okay. Now you see this has become gray, which means that this is now being sent to the queue, but is not yet queued. Once it becomes queued, it will become hash blue. Now it has become hash blue. That means it is queued. And now it has become hash green. That means the job is processing. Solid green means the job has been completed. This one is now sent to the queue. You can see it is gray. It has become hash blue. That means it is in queue. It become hash green. It means that this is in process. Once it becomes solid green, that means it's been completed. Been completed. The training of the model is completed. Now it is going to test it. We're going to test the model. Is the scoring model has been sent to the queue. This is in process, in queue rather, not in process, in queue. Once it become hash green, it will become in process. Hash green in process. Dark green is completed. And the last part should not be big one. The green, that means it is in process. Very soon it will become solid green, hopefully. If there are no errors, it will become solid green. So my entire pipeline is now complete. The job is complete. Let us see the output. So if you right click over here in the spore model and preview the data, you will see that. So here you have the income and these are scored labels. That means this is the prediction. So here you see the first one itself is wrong. Actually, it is less than 50K, less than equal to 50K, but it has been classified as more than 50K. And along with that is a scored probability. If the probability is more than 0.5, then it is being classified as more than 50K. And if it's less than 0.5, here you see, then it is classified as less than 50K. Okay. So this is exactly what happens in the classification. The classification model is actually uh, giving a probability. Also, you'll be able to see the decision tree. It's a multi-class boosted decision tree. So you see over here, and one.